Hello and welcome to Startup Hack. Today we are going to talk about in-memory pub/sub implementation using channels in .NET. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. Alright, what are channels? Channels are .NET standard implementation of pub/sub pattern and are available in the system.threading.channels and you get package. Channels comes into two flavors. Bounded has the capacity as a limit on how many items the channel can hold, and if it's full it will block the producer in an async way until it gets more space. Unbounded has no such restrictions, can be used by any number of readers and writers concurrently. Both flavors come with individual configuration options to override default behaviors. In the context of bounded channels, we can also provide a behavior on how the channel acts when it's full. Wait, drop newest, drop oldest, drop right. Basic usage of a channel following code fire and forgets tasks where while loop produces random numbers while the code subscribes to event bus changes and read from async iterator continuously. Now building our REPL library. So number one is the contracts. We will start off by introducing 4 service contracts and 2 entity models supporting our library. So here's example. This is the whole contract. The general idea is to provide to the user with an easy way of bootstrapping this event bus and defining their own type handlers. So we will also provide extension on service collection to allow the developer a nice experience. Next up, we have implementations of consumer, producer, and their service registrations. Our implementation of the producer is slim and relies on .NET Channels T. The producer wraps the provided channel, writer, and implements the interface by providing events into an internal channel. Next up, we will implement consumer. The consumer is a singleton that subscribes to certain channels he needs to listen, and once he receives message, he will proxy them to the register handlers within their scope. We get handlers via the DI container, which the user will register them in by calling our Flowing DI registration extension. So we start creating by our consumer and implementing the bare bone interface. So here's example. As mentioned, our consumer is meant to be singleton and read events from the inner channel reader that he wraps. Thus, we also supply a cancellation token source so that we are able to gracefully stop the processing. Let's implement the start method of consumer. So here's example. Next, we will implement internal start processing. The method our focus will be on loading the async iterator from the channel reader and processing the reader events. So it is available for each event. We will, as previously mentioned, set the provided metadata so it's available in the scope and create a new login scope. Once that is done, we can just kick off processing in a parallel fashion. So here's the example. Here we can improve by introducing the error handler method on the handler, retry policies around processing, and the DLQ concept. We can achieve this by encapsulating logic within IC consumer or decorating our handlers by default. However, this won't be implemented in the scope here. Now that we have finished the main implementation, let's quickly take a look at what even metadata accessor implementation would look like. This accessor implements a pattern like HTTP context in the request scope of Web API. It leverages async local to access the data async scope. So here's example. This will allow you to inject even metadata accessor in any place down the async scope and resolve even metadata in a nice and flexible way. Next up, we provide users with a nice fluent way of registering all of this. So here's example. Great, we have done it. Now let's head for the demo. We will write 3 basic demo handlers which will register and run some events through the producer. These handlers covers a few features: primitives as event, complex objects as event, multiple handlers for the same event, resolving other dependencies within a handler, consuming event context data. So here's the example. Now we run this demo in our console application. So as you can see, the console program.cs file, we will run this application from now on. So when I run this application, you can find these logs as a result. Thank you for watching this video. This is obviously a very basic implementation of an event bus. However, the interfaces we define can give us more leeway when the time comes to go into resources like Azure Services Bus, RabbitMQ, etc. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.